Dear students, welcome you all to the course that is Fabric Manufacturing Technology. Okay, so in the last sessions we have discussed about the weaving preparatory processes and particularly shuttle weaving also we have discussed. So from unit 1 to unit 3 we have discussed about what are the different processes of weaving preparatory, that is like a warp preparation process as well as the weft preparation process. And in the unit number 3 we have discussed about particularly shuttle weaving technology. So just we will recall that what is exactly in unit 1 we have discussed and unit 2 and unit 3. Okay, so that you can remember what we have learned from unit 1 to unit 3 is. Now in unit 1 we have discussed about winding and warping. So what is the objective of winding? The winding objective is to convert the smaller packages to the larger packages, that is ring up to the cone, and removal of yarn faults in the ring spun yarn. So these are the main two objectives, and we have discussed about what is exactly the drum winding and precision winding is and their individual parts. And after the winding we have discussed about the warping technology. So in warping we have discussed about what are the different types of warping machines are available, what is exactly the beam warping and what is the sectional warping is. So the warping objective is the conversion of individual yarns into a continuous sheet form. So the individual yarns we are converting into a sheet form, that too into a certain length. Okay, so we are winding this sheet into a beam which is called as the warping. So after the beam preparation, after the warper's beams or weaver's beam preparation, so this warp sheet is going to be sent for the sizing operation. So that is we have discussed in the unit number 2, particularly sizing technology. What is exactly the sizing? What are the objectives of sizing? To increase the weavability, to increase the abrasion resistance, to lay down the hairs on the yarn surface. So there are many objectives of the sizing. So we have discussed particularly in the sizing section what are the different types of sizing gradients we are using for particular quality of the yarn, like different types of yarns and their counts. What are the different types of size ingredients we are using, like out of the primary ingredients and secondary ingredients, what we are using exactly we have discussed. And the size paste preparation and what are the 2-cylinder sizing machine, different zones and the different zones present in the multi-cylinder sizing machine for the low density warp sheets and the high density warp sheets are. And along with that we have discussed about the post sizing operations. So after the sizing, the warp sheet is going to be sent for the warp sheet, nothing but the warp beam, that sized weaver's beam is sent to the drawing in and denting section, so that the drawing operation can be done. The ends are going to be drawn through the drop wires, heel wires as well as the reed. So the drawing in and denting section we have discussed, and if the same quality of warp sheet if the same quality of fabric need to be produced, then in that case we are going for the knotting operation, where the knotting is nothing but the old warp beam whatever the warp ends are there, nothing but in the running warp sheet on the loom, those ends and the new warp beam ends we are going to knot together. Individual ends are going to be knot together at the weaving zone. So there is a small machine like that is called as the knotting machine, where it can be knot the old ends and the running ends and the new ends. Okay, so these are the post sizing operations we have discussed. After the drawing in and denting operations completion, we are sending the beam to the weaving machine. So we have discussed about what is exactly the shuttle weaving technology, sir. What are the loom motions, particularly what is exactly the fabric formation is, what is woven fabric manufacturing is. So we have discussed about woven fabric manufacturing, that is weaving is nothing but interlacement of warp and weft threads to produce the cloth. So that is a major definition of the weaving, and we have discussed about what are the different types of loom motions available, or loom motions we need to form the fabric is. Like there are three major categories. One is called as the primary motions, secondary motions, and third one is called as the tertiary motions or auxiliary motions. So we have discussed about what are the different types of primary motion. What are the primary motions? So primary motions are one is shedding, picking and beat up. Shedding, picking and beat up. And the secondary motions we have discussed, such as warp let off and fabric take up. Warp let off and fabric take up. And auxiliary motions we have discussed, like warp protector mechanisms such as loose reed, fast reed, and weft to stop motions we have discussed. Side weft fork motion, center weft fork motion, and we have discussed about the warp stop motions. Warp stop motions are like mechanical type of warp stop motion and electrical type of warp stop motion. And along with that, auxiliary motions we have discussed, or auxiliary mechanisms we have discussed. The temples also. What are the different types of temples we are using in weaving? Okay, so this is all about the first unit to the third unit. Okay, now we will start the fourth and fifth units. So particularly the unit number 4 and unit number 5, we are going to discuss about the unconventional looms. Unconventional looms nothing but shatterless weaving technology. In unit number 3, we have discussed about shuttle weaving. So there is a shuttle to carry the weft yarn from one side of the shed to the other side of the shed. Nothing but one side of the fabric to the other side of the fabric. So through the shed, the shuttle is going to be passed. Nothing but the weft yarn insertion will be going to done with the help of shuttle. Okay. So now in the shatterless weaving technologies, there is no shuttle. There is no usage of the shuttle. So you can ask me like how the weft yarn is going to be inserted, sir. So we can insert the weft yarn. By using a rapier or a projectile or a air means or a water means, like fluid jets. Okay. So there are different types of shatterless looms are there. Okay. So we will look after what are the limitations of the shuttle loom and how and why these shatterless looms are came into the picture. Okay. So to whatever the developments are taking place, so to overcome the drawbacks of the present or drawbacks of the particular technology, we are going to take the drawbacks and we are going to rectify the drawbacks. Okay, and we are getting more efficient and we are getting more productivity so that the industry may get profits. Okay, so that is why there is any development one to the other. Okay, so let us discuss about particularly this session about the limitations of an ordinary loom. Limitations of an ordinary loom, or you can say that limitations of a shuttle loom. Limitations of a shuttle loom. So we will discuss one by one what are the different limitations, what are the particular limitations of the shuttle loom is, and how it was overcome in case of shatterless looms are. So before going to the particular content, so we will see that the unit number 4, what are the different contents available. So you can see here, there are like limitations of ordinary loom and the classification of Shatterless loom or Shatterless weaving machines, and we have particularly we are going to discuss in this session or in this unit, we are going to discuss about the projectile weaving technology and the rapier weaving technology. Okay, so these two machines we are going to discuss in the particular unit. Now we will see that what are the limitations of an ordinary loom is. So most of the people know that, so the particular limitations we will discuss one by one. So what is exactly the weight of the shuttle is approximately, the weight of the shuttle is 450 grams to 500 grams. This is going to be depends upon the type of shuttle, type of loom, and what is the content of FT which is going to be employed or which is going to be there in the case of shuttle. Okay, so now to transport the shuttle from one side to the other side, so we required a large energy consumption, nothing but we required more force to travel or transfer the shuttle from one side to the other side. So but what is the thing is, we required only particularly like about 0.2 grams per meter of FT is need to be inserted, but how much amount of shuttle we are transferring from one side to the other side? It is approximately 450 grams. It is approximately 450 grams. So now if you understand 0.2 grams per meter of the FT per epic, but we are transferring the shuttle, total shuttle, that is 450 grams. So there is a large energy consumption. Okay, so the more amount of force is required to transfer the shuttle. That is one of the drawback. Okay, so instead of one peak only insertion, so there is no choice that we require to transfer the shuttle from one side to other side. So we are transferring the shuttle through the shed from one side of the loom to the other side of the loom. So more amount of energy is consuming in this particular case. To insert 0.2 grams per meter of the FT, we are transferring 450 grams of, that is weft package including the shuttle. Okay, so now unguided free flight of shuttle can lead to fly. Okay, lead to shuttle flight, and there is an abrasion damage of reed and shuttle as also controlled weft tension. So there is, like you can see that the shuttle is to be flight on the inside of the shed, and along with that when the shuttle is traveling in the shed, so there may be chances of damage of the reed or damage of the shuttle, and due to the abrasion in between the race board and the shuttle, so there may be chances of damage of the warp threads also going to be occur. Okay, and there is no uncontrolled weft tension is going to be there because the shuttle is having the weft package, and whenever the shuttle is going, that time the yarn withdrawal is going to be occur from the weft package. So there is no controlled weft tension. There is no controlled weft tension. That is why it is uncontrolled weft tension there in the shuttle. So now this is the one of the drawback. So the damage of the reed shuttle, and there may be chances of flight of the shuttle. Then there may be chances of abrasion of the yarns or damage of the yarns because of the abrasion between the shuttle and the yarns and the race board. Okay, because in between the race board and the shuttle, so the shuttle is transferring on the race board, and in between that there are warp threads. So obviously there is an abrasion is going to be occur in between the shuttle and the warp threads. Okay, so these are the two things, and we have here the shuttle checking within the confined space of shuttle box results out of multiple impacts. So consequently the exact location of the rest position of shuttle within a box becomes indeterminate. So there is no possibility, that there is no idea about that where the shuttle is going to be stopped exactly in the shuttle box, because there is no positive mechanism, there is nothing to hold the shuttle. So the shuttle is traveled from one side of the shuttle box to the other side of the shuttle box. Okay, so in the shuttle box where it is exactly going to be placed, so it will not be determined. So maybe it will be at the back end if the force is sufficient. If it is force is more, it go back and it comes back to the front position. So it is not determined, and affecting the efficient transfer of peaking energy. So it leads to the energy of the peaking energy. So sometimes, for example, if the shuttle is at the back side of the, nothing but at the end of the shuttle box, the force is different. If the shuttle is placed in the just in the starting of the shuttle box, the energy for peaking is going to be different. So during acceleration of the shuttle, it is going to be varying. So the acceleration of the shuttle is going to be varied. Moreover, such impacts results into a damage to shuttle or pun sometimes. Okay, so there may be chances of damage of the pun or the shuttle can be occur because of the acceleration of the shuttle is going to be varied in the shuttle box. And mass of the shuttle with full pun and near empty pun can be differ by about 10% weight. So nothing but, if the yarn content is there in the shuttle, full cup, full pun, so now it becomes 450 grams. So as I told earlier, pun weight is approximately 80 to 100 grams. Now the goes on, weft insertion is happening, goes on, what will happen? Goes on, the shuttle weight is going to be reduced. So from full to the empty pun, the shuttle weight is going to vary about 10% of its weight. So as a result, the nature of shuttle flight varies in a periodic manner, which in turn affects weft tension profile and therefore properties of the resultant fabric. There is a chance of, so the fabric quality, there is a chance of fabric property changes can be occur because of the weight changes or mass changes of the shuttle. Okay, so this is the one of the limitation, and there is huge amount of noise, approximately as high as like 110 decibels of noise is going to be produced in conventional looms. And shuttle is made of an assembly of various elements which come apart over a period of time due to multiple and severe impactual cyclic loads. Okay, there are so many parts which are involved or which are there in the shuttle. So these components are majorly like a wood shuttle is going to be used. So this wood shuttle may be, so the goes on running, it may be like a wear and tear can be occur. So this is one of the thing, and the elements which are there, so particularly the elements also going to be worn out, or the breakages of these particular elements. And the tips of the shuttle is generally made up of like metallic tips are there. So these metallic tips, if the shuttle flight is occur and it goes away from the loom and it damages the shuttle parts, so in that case again we need to go for the polishing as well as the change of the shuttle may have to be done. Okay, so these are the things. Then the limited space within the shuttle limits the pun size. So nothing but the shuttle size is limited because you cannot go for the bigger shuttle, because if you go for the bigger shuttle size, if you increase the dimensions of the shuttle, so you can accommodate the weft package, but what is the weight of the shuttle? Weight of the shuttle is goes on increasing. If you increase the dimensions of the shuttle, the weight of the shuttle is going to be increased. So what will happen? You required more force or more energy to transfer the shuttle from one side to the other side. Along with that, again if you increase the dimensions of the shuttle, shed depth, shed opening should be more. So if you open more shed, then you are going to strain the warp sheet. So if the strain is more than the yarn strength, so the yarn breakages can be occur. So there is a limitation of the shed opening. So that is why the shed and the shuttle both should be interconnected. So now as per the shed depth opening, we need to go for the shuttle height. So the shuttle height is determined by the particular shed opening. Okay. So that the pern size is limited. So generally the pern weight is like I told, like 80 grams to 100 grams of the pern weight. So there is a limitation, like frequently we need to change the pern. Nothing but, say for example, if you have 80 grams of pern weight and it is coming around 8 minutes or 10 minutes of time. So after 10 minutes again we need to change the pern. Okay. So that what will happen if you frequently changes, more changes of pern is there. So idle time of the weaving machine is going to be increased. So you are not going to get the machine efficiency. So idle time is going to be more, running time is going to be decreased. So you are not going to get the efficiency, and which is going to like sometimes this is going to be affects the fabric defects also, because frequently we are changing the pern, and whenever the loom is stopped, along with the loom stoppage, again we are changing the pern. Okay, we are changing the pern after the exhaustion and we are starting the loom. So when we are changing the loom, at the time the warp threads are relaxed. Now again we are starting the loom. So at the starting of the loom, again the strain on the warp sheet is going to be nothing but the tension on the warp sheet is going to be applied. So at the time what will happen, the starting marks on the fabric is going to be visible. Nothing but pick spacing from the old weft package to the starting of the new package, that whatever the two picks are there, the two picks distance or gap or space in between the two picks are going to be changed. So because of that, there is a starting marks. Okay, you can see that the restarting the loom with a new pern invariably causes a starting mark in fabric, while imposing a periodic workload on a loom operator. Okay, so along with that, again periodically the workload on the loom operator or weaver is going to be increased, and on a pern changing loom one needs an additional. For example, if we incorporated, or if you have kept a separate mechanism to change the pern automatically, so whenever it is exhausted, it will read and it will going to change the pern. For example, if we have that type of mechanism in the shuttle loom, so that is called as the pern changing mechanism or the weft replenishment mechanism. So where the pern is exhausted, this mechanism will identify and it will be going to activate the pern changing mechanism. So automatically the old pern is going to be pushed down and the new pern is going to be inserted in the shuttle. So there are small adjustments are required in case of shuttle also. So the shuttle design and shuttle parts are going to be different for the particular case. So if we have that type of mechanism also, then we need an additional worker to replace the or to mount the weft packages in the magazine of the weft changing mechanism. Okay, so additional workers are required if we want to use this particular type of mechanisms. Okay, so this is how. So along with that, we are required the pern changing machine or pern preparation. Pern changing mechanism is required, again additional cost, and we required additional worker to place the perns in the magazine of the pern changing mechanism. Okay, so this is one of the drawback. So manpower, wages on the particular man is going to be more. Then you can observe that two images where you can see that there is a shuttle and there is a fell of the cloth. So at the end of the fell of the cloth to the shuttle eye, there is a part that is called as the shuttle eye. So from in the inside of the shuttle we have a pun. So the pun, from the pun we are taking the yarn through the shuttle eye. Through the shuttle eye, there is a small hole in the front wall of the shuttle. So through that particular hole that is called as shuttle eye, we are taking the warp weft thread. So this thread distance from the shuttle eye to the fabric selvage at one side, that is called as, you can observe that it is like your left side of the machine, and you can observe that the second image where from the shuttle eye to the selvage, the distance, you can observe the distance between the selvage to the shuttle eye. So you can observe that left side is smaller than the right side. So right side is some more length is there. So you can observe that whenever the shuttle is transferring from the right side to the left side, that time what will happen? The weft thread is becoming slack. Weft thread is becoming slack, whatever the distance is there. So after particular distance insertion, then it will pull the weft thread from the pun. So the slackness is going to be there in particular case. Okay. So this case, this is also one of the drawbacks. Sometimes if the yarn is having fault, like if the yarn is having weak place and particular place, so when the slackness to the tightness is there, nothing but when the slack, after the slackness is straightened, after the slack yarn is straightened, so now the yarn content has to be released from the pun. So when it is releasing from the pun, that time what will happen? The force applied on the yarn is going to be vary. So the force is that whatever the acceleration on the weft yarn is going to be differ from this place to the end of the pick. So it may leads like if it is weaker place, sometimes there may be weft breakage also can be done. So this is one of the drawback. The particular weft length on the both the sides of the loom is not same. So that is a major thing, and I have listed out. So whatever we have discussed, I have listed out some of the points here. Shuttle looms cause more noise, as I told, as like 110 decibels of the noise we are generating in the shuttle looms. And shuttle causes abrasion on warp yarns also there, so that increasing the wastage percentage. Warp breaks increases for the shuttle. Okay, the production rate of the shuttle is slower than the shuttle-less looms because there are so many mechanical elements are there. So every 10 minutes we need to change the pun. Okay, so idle time is becoming more. That is why we cannot able to run the machine at higher speeds also. And one of the thing is like there are so many mechanical elements which are involved in the production of fabric, in particular to shuttle looms. So by considering all these mechanical components and the technologies involved in the shuttle looms, so we cannot able to go for more than 220 picks per minute in a shuttle looms. Okay, sometimes shuttle flies from the shed and can cause an accidents also can be done, because the shuttle maybe like if the shuttle is getting on vibrations because of the acceleration is changed, so maybe chances of the shuttle flight nothing but it is coming out from the shed and it is going away from the loop, and it may damage or it may cause an accident or it may damage the shuttle even. Okay, and there is a higher labor cost, and we required particularly pun winding also we required to prepare the pun preparation, that is weft package preparation. Okay, and efficiency of the shuttle looms are less than the shuttle-less looms. So obviously there are manual things more So automizations are less, and every time we need to change the pan, and we need to remove the shuttle, we need to change the new pan, and we need to again insert into the shed and starting the loom by manually. It takes lot of time. Okay, so as compared to the shuttle-less looms are continuous. So if you start the loom without any breakages, it can run up to 2-4 hours also, if there is no breakages occurred in weft yarns or warp yarns. Okay, and increase the physical and mental pressure on the labor also. Labor nothing but the manpower. So in it is like we are allocating 2, 3, 4 looms to the one person or one weaver. So every time he has to monitor all 4 looms to get more efficient production and to get good quality of the fabric. So in terms of quality also, if you compare with the shuttle-less looms, the shuttle looms quality of the fabric and the appearance of the fabric may be like a low quality. Okay, low quality nothing but it is like having some fabric faults or producing some fabric faults in the shuttle looms compared with the shuttle-less looms. Okay, so these are the drawbacks of the shuttle looms, and we will see that what are the features of the shuttle-less looms are. So the shuttle-less looms can weave 2 to 4 times more than the shuttle-less looms. Now it becomes like 200 I told, right? 200, 220 I told. You can run the shuttle looms at 800, 1000, 1400 picks per minute. Picks per 1 minute. Number of weft threads insertion per 1 minute, you can go up to 1400 even in the case of air jet looms. Okay, so that is why the production rate becomes very high. And the cost of the pern winding, complete pern winding is eliminated. That is, weft preparation process is eliminated. In you can eliminate the weft preparation process. That is, pern winding machine can be in. So whatever the machine and the labor or manpower we are allocating to the preparation of pern, which is neglected, which is removed off. And strain upon the warp. And strain upon the warp threads is reduced due to smaller depth of shed. So we are using the rapier, projectile or air. So we require only small opening of shed. We don't require much more larger shed opening, because the rapier is having a very thin diameter and the projectile also having very thin diameter, or thickness is very smaller thickness. So we don't require that much of shed opening. So automatically strain on the warp sheet is going to be reduced. Okay, because of the smaller depth of shed opening. So heavy cost of repairs and replacements of worn out parts is going to be reduced, because if more number of mechanical components are there, more mechanical components, that too abrasive mechanical components, like in case of you can understand that there is a cone over peak mechanism, there is a cam and there is a nose which is going to abrade every time, which is going to push the cone. The cam is going to push the cone every time. So there is a damage or worn and tear out the parts of mechanical components are there. So again, to change that particular things are eliminated in these particularly shuttle-less looms. Okay, so that is the thing. And physical and mental strain upon the weaver is reduced, because everything is modernized and everything is automized. So the strain on the weaver, so nothing but in case of, if you observe that there is a let off motion, so negative let off, every time the worker has to change the dead weight position on the loom. Okay, and again he has to attend the breakages, he has to attend the pern changing, and he has to see that the breakages and the fabric quality. So the cleaning of the weft elements or weaving elements. So there are so many works in case of shuttle looms. Now all are reduced in case of shuttle-less looms. That is why the physical and mental strain on the weaver is going to be reduced. And no risk of flight of shuttle. There is no shuttle fly. There is no shuttle use. So there is no fly of the shuttle. and quality of the fabric get enhanced because of the positive control of the weaving process. So everything is like a motorized and it is going to be controlled positively with the help of servo motor drives and with the help of electronic means we are controlling all the mechanisms, so automatically you will get the fabric quality, good quality. Okay, and looms are easier to work and manipulate. You can work very easily. Anyone can attend the loom, anyone can learn the loom mechanisms, and the manipulation nothing but you can change if you want to change the quality from one quality to other quality. So there is a completely control panel system where you can change whatever the quality requirements are required. Like if you want to change the picks per minute, you can automatically change the picks per minute in the loom by just giving the instructions to the microprocessor. So the microprocessor will control how much of the speed of the warp let off and the fabric take up has to be done, so that we can maintain the number of picks per 1 inches. Okay, now that is picks per inch, it can be controlled automatically. Like these mechanisms are there so that it can be very easily monitored and we can get the good quality of the fabric. So efficiency of the shuttle weaving shed is comparatively shuttle-less weaving that is. So efficiency of shuttle-less weaving shed is comparatively higher than the shuttle weaving. So automatically, like if you have all control systems, so you will get the more efficiency and more productivity. Okay, so that is the thing, and you can have higher production per loom also because of the more running time compared to the shuttle looms. So idle times are reduced in case of shuttle-less looms. Okay, so these are the salient features, some of the features of shuttle-less weaving technology compared to shuttle weaving. Okay, so these are the things, what are the limitations and what are the features of shuttle-less looms. So in the next session we will discuss about the classification of shuttle-less weaving machines. So till then, thanks for listening. Bye.